Hello everybody and welcome to Unit 2, Day 1. Hopefully you all did well in your Unit 1 test and you're ready to start on a new unit. There's a lot of vocabulary here in this unit, so pay close attention. We will go through it. I will give you the definitions and sketches of a lot of these things that we have here. First thing we have is a point. A point is represented by a dot on the graph. As you can see here in the sketch area, we would call this point P. A line is represented by a line with arrowheads on both sides. This one would be called line AB. You can see these 2 points are on the line, and we would write it as AB with a line with 2 arrows over it. The next figure we're going to talk about is a plane. A plane is represented by a shape that looks like a floor or a wall. You can see here, it needs to have at least 3 points on it in order to name the plane. We'll get into how to name them in just a minute. Collinear points. Collinear means together on a line, so that's points that lie on the same line. So here you can see a line that has points M, N, O, and P. Those points would all be collinear. Coplanar points would be points that are on the same plane. Here you have a plane that has points A, B, and C on it. Points A, B, and C would be coplanar. Sometimes we don't have a whole line, we just have a piece of a line. We call that a segment. This particular one would be segment PF, even though over here it says written as segment AB. It's named after its endpoints. So P and F are the 2 points at the ends of the segment. We call those endpoints. Next up we have a ray. A ray almost looks like half a line. It has what we call an endpoint, and it goes in one direction. So this would be ray HS. It starts at point H, it goes through point S, and continues on in that direction. Next definition we have are opposite rays. Opposite rays are 2 ends that share an endpoint but go in opposite directions. So here this is a line because opposite rays do form a line, but we have ray ML starting at point M and going to the left, and we have ray MN starting at point M and going to the right. So they are opposite rays because their points they go in opposite direction from the same endpoint, which in this case is M. What we're going to do now is a quick review of the properties of some properties you learned from algebra. First, we're going to talk about the addition. It says P of E, or sometimes I'll abbreviate it as POE. That just stands for property of equality. So the addition property of equality tells us that if you add something to the same side, or if you add the same thing to 2 sides of an equation, you still have a valid equation. So here's an example. If x equals y, then x plus 3 equals y plus 3. We've just added 3 to both sides of the equation. That's the addition property of equality. The subtraction property of equality is very similar, except we're going to subtract the same thing from both sides. So if m equals n, then m minus 4 equals n minus 4. Next up we have the multiplication property of equality, which, just like addition and subtraction, says that if you multiply something to both sides of an equation, you still have a valid equation. So here you can see if g equals h, then g times 2 equals h times 2. And not surprisingly, the division property of equality is going to look very similar. Here it says if a equals b, then a divided by 5 will equal b divided by 5. We can divide both sides by the same thing and we still have a valid equation. There's some other properties that are not properties of equality, but they're just properties. One is the distributive property. The distributive property tells us that 4 times the quantity of x plus 2, we would just take this 4 and distribute it to both things inside the parentheses. So 4 times x gives us 4x, 4 times 2 gives us 8. So 4 times the quantity of x plus 2 equals 4x plus 8. The reflexive property, a lot of people get these next 3 properties confused. Reflexive, just think reflection, like in a mirror. J equals J. Okay, 4 equals 4. Pretty simple. The symmetric property we'll have two different things. So if V equals W, then W equals V. You can just take it and turn it around. The transitive property will involve three different things. It's going to look very similar to the law of syllogism, which we talked about in Unit 1. This tells us if P equals Q and Q equals R, then P equals R. Kind of like in the law of syllogism, we can get rid of the thing that repeats, and whatever we're left with will be a valid conclusion. Substitution property just says if we have two equal values, we can substitute one in for the other. So here, if U equals 7, then 10 minus U equals 10 minus 7. We've just substituted in a 7 for the U, and that's the substitution property. If you turn the page, we're going to look at some problems here and see which property was used. We'll see how we do on these. I think you guys will be pretty good. So number 1 tells us 3 times the quantity x plus 4 equals 3x plus 12. What property are we using there? That's right, it's the distributive property. We'll talk about number 2 in class because that's not one of the properties there, but it's a property you should remember from algebra. So if you have a guess here, if 3 times the quantity of 2 times 6 equals 3 times the quantity of 3 times 2 times 6, see if you can get what property that is. It's not one of the ones listed on the previous page. Number 4, we have 4x plus 6 equals 12, and the next line tells us 4x equals 6. Well, we had a plus 6 here and we don't anymore. So what we did here is we subtracted this 6. If we subtract it from one side, we have to subtract it from the other side. And the property that tells us we can do that is the subtraction property of equality, or you can abbreviate that POE if you like. Number 4, we have 2x equals 6. That turns into x equals 3. Here we had 2 times x and a 6. To get rid of the 2 times x, we're going to divide to just get the x, but if we divide on this side, we have to divide on the other side. So that is the division property of equality. Here in number 5, x minus 3 equals 9, and then we're left with x equals 12. Well, to get rid of this minus 3, we had to do a plus 3 to both sides, so that's the addition property of equality. And here in number 6, we have x divided by 3 equals 7, and that turns into x equals 21. So since we have a division here, to get rid of it, we do a multiplication. If we multiply by 3 here, we have to do it here, and the property that lets us do that is the multiplication property of equality. Moving right along, number 7, if I know that x equals 6, then 3 times x plus 2 is going to equal 3 times 6 plus 2, because I substituted in this 6 for the x that I had. So that is the substitution property. Here, if x equals 6 and b equals x, then b equals 6. So the x's repeat, I can get rid of them, I'm left with b equals 6. That's the transitive property. Y equals y, something equals itself. Again, think of a mirror and a reflection. That's the reflexive property. X equals 6, so 6 equals x. That is the symmetric property. For some reason, this property was the one most picked on proofs last year, even though I don't think it was ever the right answer. Here's a couple other definitions for you. Postulates. Postulates are things that cannot be proven, but are accepted as true. Theorems are statements that have been proven. And a proof, and some of you probably heard bad things, and you're thinking bad things, bad feelings about proofs, but don't. Proofs are fine. Proofs is when you're giving reasons for steps, the steps you take while you're solving problems. And we're going to do an example of that right here. Everybody excited about doing their first proof? Good. So here we've got A. It says solve each problem and write the reason for each step. Well, in this one, I solved the problem for you. All you have to do is come up with a step. So we start with 2x plus 5 equals 30 minus 3x. That's what was given to us. So I can see the exact same thing is written here on the first line, and because that was given to us, we're just going to call that the given. So the reason for that is given. That's the reason. All right, now we went from 2x plus 5 equals 30 minus 3x to 5x plus 5 equals 30. Well, it looks like this 3x isn't here anymore. we must have moved it over here. If it was a minus 3x, the only way to move it over here would be, that's right, to add it. And what lets us do that? The addition property of equality. Excellent. You guys are doing a great job. So from 5x plus 5 equals 30, we get 5x equals 25. Here we have a plus 5. If we subtract it from both sides, that'll give us this 5x equals 25. And we can do that by the subtraction property of equality. And finally, to go from 5x equals 25 to x equals 5, we're going to divide both sides by 5, and that is the division property of equality. All right? I'd like you to try to do B on your own. Go ahead and solve the problem and write the reason that you're able to do each step. So whatever you're doing in each step, that's probably the reason. If you're adding, it's the addition property of equality. If you're subtracting, it's the subtraction property of equality, and so on and so forth. The other things on here, there's several more proofs on here. I would like you to hold off on those. We're going to go over those in class. And the last page, you have the bonus notes. We'll also go over that in class. That's all for your notes today. We will see you in class tomorrow.